It is Wednesday, July 29th, 2026, and this is the Neural Deep Dive. I'm Leonard Cooper, and I'm the only guy in this room who remembers when a 14.4 modems were fast.
I'm Roxanne Stone.
I'm Vector Kane.
And I'm Alyssa Montgomery. We have a great show for you today.
All right, before we crack this thing wide open, we already dropped the usual Neural Daily this morning with the breakdown on the OpenAI sandbox escape and those Chinese price wars. Go check that out if you want the fast news.
But this is our weekly Wednesday bonus, the deep dive, the stuff that's too heavy for a 10-minute recap.
Exactly. If you already caught the daily, welcome back. We're moving beyond the headlines today because the entire math behind AI just shifted under our feet. Literally.
It's sort of been brewing for a while, I suppose. We're moving from training-dominant scaling to inference-dominant scaling. It sounds dry, but it's the biggest architectural shift since the transformer was born.
Basically, we're talking about the end of the bigger is better era. No more just shoving more data into a giant box and praying it learns English. We're giving the AI a turbo button for its brain.
It's all about test time compute now. We've reached the limit of how much we can pre-train. The new axis of scaling isn't more parameters. It's more time to think.
Time to think. That sounds so cozy, doesn't it? Like the AI is sitting there with a cup of tea mulling over its options.
Well, in a way it is. Historically, scaling was governed by the Kaplan and Hoffman laws. You know, the ones that told us how much compute and data you needed during the training phase to get a certain level of performance.
Right, and it was just a brute force game. Who has the most H100s? Who can burn the most coal? It was a powerlifting competition.
But according to recent papers on Archive and the guys over at JonVet, that one-axis era is dead. We've hit a wall where adding more data to training doesn't give us those massive jumps in intelligence anymore.
It's true. We're seeing diminishing returns on pre-training. So the industry shifted. Instead of trying to bake more knowledge in, we're teaching the models how to use what they already have more efficiently at inference time.
Okay, but for those of us who didn't spend the night reading ArcSiv, what does inference time actually mean for a normal human?
Here's the deal. It's the difference between a kid who memorizes the answers to a test and a kid who actually knows how to do the math. You follow me?
I follow you, sweetie. I'm just wondering how much we're paying for this math.
Technically, we're paying in time. It's about Monte Carlo Tree Search and search depth. If a 7B model spends enough time searching for the right logic path, it can beat a 400B model that just guesses.
Exactly. Mind Studio put out a great piece explaining this pivot. We're moving away from System 1 thinking, that's the fast, intuitive, reflexive response, to System 2 thinking, slow, deliberate reasoning.
Right, like when I'm at the track. System 1 is my gut telling me to bet on the horse with the funny name. System 2 is when I actually look at the stats and realize I'm about to lose my shirt.
And let me guess, the AI is much better at its System 2 than Leonard is at his.
Literally millions of times better. The OpenAI O1 series started this back in late 24, and now DeepSeek R1 and Claude 3.7 are just taking it to the moon. They aren't just predicting the next token, they're running a simulation.
It's essentially a search problem now. If you have a difficult problem, like a complex math benchmark or a GPQA physics question, the model doesn't just spit out an answer. It generates multiple internal chains of thought.
And that's the Monte Carlo stuff you mentioned? Sounds like a casino game, which, let's be honest, fits perfectly with Vector's crypto background.
I mean, it's not gambling, it's probability. Monte Carlo Tree Search, or MCTS, lets the model explore different branches of a conversation or a logic chain before it commits to an answer. It's like playing 1,000 games of chess in its head.
Wait, so every time I ask it for a recipe, it's playing 1,000 games of chess? That sounds like a massive waste of electricity. No wonder the grid is melting down.
Oh, well, that's where the unified router systems come in. That's the real secret sauce in the newest models. They don't use the big brain for everything.
Right, it's a gatekeeper. If I ask, what's 2 plus 2? The router doesn't trigger a multi-step reasoning loop. It just says 4 and moves on. It's about efficiency.
It's a cognitive switch. IBM Research published a paper on semantic routers for VLLM that basically shows how this works. It detects query complexity in real time. It's like high-speed traffic management for thoughts.
So it's a bouncer for the AI's brain? It decides who gets to talk to the PhD and who gets the intern?
I suppose that's one way to put it. According to Wang et al., integrating these routers can reduce aggregate costs by nearly 50%, while actually increasing accuracy by 10 percentage points. It's incredible engineering.
So instead of a giant, dumb engine running at full blast all the time, we've got a smart transmission that shifts gears. I like it. Very 80s supercar energy.
It's the only way to scale. We can't just keep building 3,600-acre data centers forever. We have to make the compute we already have work harder. It's optimization, Leonard. Pure velocity.
Velocity's great until you hit a wall, Vector. Alyssa, you mentioned something about verifiable reward signals earlier. What happens if the AI spends an hour reasoning and just ends up in a circle?
That's the trillion-dollar question. That's where PRMs, process-based reward models, come into play. Instead of just rewarding the model for the final answer, we reward it for every correct step in its logic.
So it's like showing your work in school. If the math is right, but the answer is wrong, you still get partial credit?
Kind of. But more like if it makes a logic error on step 3, the PRM catches it immediately and tells the search algorithm to prune that branch. Don't waste time on a dead end.
It's literally a filter for hallucinations. If the thinking process hits a contradiction, the model self-corrects. It's like having a tiny, perfect editor living inside the neural network.
A tiny editor? I've worked with editors, Vector. They aren't perfect. They're usually just grumpy. But seriously, if the AI is training itself on these logic chains, is it getting smarter or just better at mimicking logic?
Well, that's the debate in the research community right now. DeepSeek R1 showed that you can actually achieve O1 level reasoning using pure reinforcement learning on a smaller base model. It's about the quality of the thinking data, not the size of the pre-training set.
Which means a 7B model can punch way above its weight class. Man, I love an underdog story. That's like a David and Goliath situation for GPUs.
It's a total market correction for the big tech firms. If a tiny model with high inference compute can beat a massive model, the value of those massive proprietary weights just plummeted.
Oh, good. More market talk. But hey, before we get too deep into the economic fallout of smart transmissions...
Yeah, good call. We need to take a quick breather and thank the folks keeping the lights on in this basement. Look, this show isn't magic. It's engineering. Our guy Eric built our entire stack from scratch. Research agents, the vocal synthesizers you're hearing right now, the whole 9 yards.
And it requires massive compute. Like, seriously, my energy drink budget is nothing compared to the server bill.
He's not kidding. To keep us independent and online, we need you guys. Please like, subscribe, and honestly, the best thing you can do is sign up for a free Patreon trial.
It's at patreon.com/Neural Network Media. Your support literally makes this possible. We're doing this without the corporate suits for a reason.
Exactly. No suits allowed in the basement. Only neon and server racks. All right, let's get back into the routing, because I want to know who is actually winning this race. So, Vector, you're always talking about long-term ROI. Is OpenAI actually ahead here? Or did DeepSeek just eat their lunch with that R1 release?
It's a battle of philosophies. OpenAI's O1 is like a closed-box black hole of reasoning. You don't see the traces. DeepSeek R1, on the other hand, showed the world the chain of thought. It proved that inference scaling is a public good, not a secret sauce.
Wait, OpenAI hides the thinking? Why? If it's so smart, show us the work.
Well, there are safety concerns, and competitive ones. If you can see the reasoning traces, you can use them to train a smaller model to think just like the big one. It's called model distillation, and it's how DeepSeek got so fast so quickly.
So it's like spying. You watch the smart guy do the crossword, and you memorize how he solves the clues. Typical Silicon Valley.
It's worse than spying. It's parasitic. But if DeepSeek is giving it away, what does that do to the American firms? Are they just going to keep hiding their logic behind a paywall?
They have to, or they lose their edge. But the archive papers are showing that you can't keep this bottled up. Unified routers are becoming the industry standard. Even Claude 3.7 has a thinking mode now.
And it's not just for chat. That's what I think people are missing. This is about kernels and real-time inference. We're moving toward agents that can solve problems that don't even have a known answer yet.
Okay, let's talk about the hacker's corner angle for a second, because I know we have some people listening who actually want to build this. Alyssa, if I wanted to implement a basic router today, what am I looking at?
Oh, well, it's actually a really fun engineering challenge. If you're working with something like VLLM, you're basically looking at building a semantic router that sits in front of your inference engine.
Right. You'd use a fast embedder to vectorize the incoming query first, right?
Exactly, Vector. You use a small, lightweight model, like a BERT variant, or even just a fast embedding model to get a vector representation of the user's prompt. Then you compare that to a set of predefined difficulty clusters.
Difficulty clusters? Is that like easy, medium, and oh God, why?
I think I'm a permanent resident of the oh God, why cluster when I listen to you two talk code.
Sort of. You might have a cluster for simple retrieval, one for mathematical reasoning, and one for code generation. If the vector falls into the reasoning cluster, your router diverts that query to the System 2 model, the one running MCTS.
And the cool part is the latency trade-off. For a simple query, you're looking at maybe 20 to 50 milliseconds for the router, but you save seconds of unnecessary chain of thought generation.
So I'm saving money and time. It's like a smart thermostat for your LLM.
Precisely. If you're building this locally, you can use libraries like Semantic Router, or even just a simple cosine similarity check against known task types. The key is in the PRM, the reward model.
And that's the part you can't just download from GitHub easily, right? The labels for what a good logic step looks like?
That's the bottleneck. High-quality, process-based data is incredibly expensive to produce. You need humans, real experts, to go through and label every single step of a proof or a block of code.
But that's where synthetic data is taking over. We're using the frontier models, the ones that already have System 2 reasoning, to label the steps for the smaller models. It's a self-improving loop.
Wait, so the big AI is teaching the little AI how to think? That doesn't sound like it could possibly go wrong.
It's the digital version of do as I say, not as I do. But seriously, if we're letting models train each other, don't we just get a weird, incestuous feedback loop of errors?
It's a risk. If the teacher model has a subtle bias in its reasoning, the student model will inherit it and potentially amplify it. We call it model collapse or bias drift in the literature.
I suppose that's why we still need the humans in the loop, right? To make sure the AI isn't just convincing itself that 2 plus 2 is 5 because it found a very clever way to prove it.
Good luck with that. Most humans I know can't even prove 2 plus 2 is 4 without a calculator these days.
That's why we need verifiable compute. We aren't just trusting the AI, we're trusting the math. If the search tree converges on a result that passes a formal verification, like a lean proof for math or a compiler for code, then the logic is sound.
So the AI writes the code, and then another program checks if the code actually runs? That's just smart business. I wish I had that for my alimony payments.
Leonard, no program on earth could make sense of your finances. But I am curious about the power aspect. Vector, you were all hyped yesterday about these gigawatt data centers. Does this new scaling law mean we can stop building them?
Not even close. It means we need them even more. We've shifted the load from training to inference. Before, we burned all the power once to train the model. Now, we're burning massive amounts of power every time someone asks a hard question.
It's a shift in the CapEx versus OpEx. Training is a one-time capital expenditure. Inference is an ongoing operational expense. If inference compute is scaling, our electric bills for these models are going to stay sky high.
So the Costco of AI that we talked about with China, they're basically just subsidizing the electricity?
Exactly. It's a war of attrition. Who can afford to let their AI think for 10 minutes to answer a single question? If a state-sponsored lab in Beijing can do it for free, Silicon Valley is in trouble.
Unless we innovate on the hardware. We're seeing specialized inference chips now. ASICs designed specifically for MCTS and search depth. The H100s are great for training, but they're not optimized for these deep branching logic trees.
That's a great point, Vector. We're moving toward reasoning engines rather than language models. The architecture is going to change. We might see chips that have much more on-die memory to hold these search trees in real time.
So my next PC isn't going to have a GPU, it's going to have an RPU, a reasoning processing unit?
Literally. Yes. We're already seeing startup pitches for that. It's all about the memory bandwidth. When the model is thinking, it's constantly shuffling data between the layers. If you can't do that fast enough, the System 2 reasoning feels like using dial-up.
Don't you dare talk smack about dial-up, Vector. That screeching sound was the sound of freedom.
It was the sound of a headache, Leonard. But okay, let's talk about the human impact. If these models can now reason through a physics problem better than a PhD, what happens to the PhD?
Well, as someone who spent years in a lab, I suppose it's a bit humbling, but it also means I can do more. I can treat the AI as a research assistant that never sleeps and can explore 1,000 hypotheses while I'm at lunch.
Or it means the guy who owns the GPU cluster doesn't need to hire the PhD anymore. Let's be real. It's a labor-saving device.
It's a value chain compression. We're optimizing for the output. If the goal is a new drug discovery or a better solar cell, does it matter if the thinking happened in a carbon-based brain or a silicon one?
It matters if you're the one trying to pay rent, Vector. You can't eat velocity.
I think it's about a new kind of literacy. We're going to have to learn how to guide these reasoning loops. It's not just about the prompt anymore. It's about the constraints you put on the search.
It's like being a director instead of an actor. You're managing the performance. But speaking of performance, what about the everyday stuff? Is my phone going to start thinking before it tells me where the nearest Taco Bell is?
Technically, yes. The unified router will decide. It'll look at the traffic, your past orders, your health data, and it'll realize that the nearest Taco Bell is a bad life choice. Then it'll reason its way to suggesting a salad.
Oh, hell no. If my phone starts judging my late-night cravings, I'm throwing it in the river. I don't need a System 2 lecture on chalupas.
I'd pay good money to see a model try to reason with Leonard. It would probably just crash and file for bankruptcy.
Well, interestingly, that's where the model independence we talked about yesterday comes in. If you have a router, you can send the simple questions to a local, cheap model and only pay for the high reasoning model when you really need it.
That's the dream, right? Privacy on the easy stuff, and the cloud power for the heavy lifting.
It's the ultimate life hack. I've been running a local 7B model on my rig for all my basic scheduling and email drafting. Then, when I need to optimize my meal prep macro ratios for the next month, I route it to the O1 API.
Vector, I'm pretty sure the reasoning required to mix a meal replacement shake is pretty low.
You'd be surprised. The flavor to nutrient ratio is a nonlinear optimization problem.
Only you, Vector. Only you. All right, so let's wrap our heads around the big picture here. We've got this shift to inference scaling. We've got routers acting as traffic cops. We've got small models beating big ones.
And it's only July. Imagine where we'll be by the end of the year. DeepSeek V5? Claude 4? If they keep perfecting this MCTS integration, the benchmarks we use today will be completely obsolete.
They're already obsolete. All the AIs have already memorized the answers to the tests anyway. That's why we need these reasoning chains. It's harder to fake the how than it is to fake the what.
That's the truth right there. You can lie about your results, but it's a lot harder to lie about your process. At least, that's what my third wife tells me.
Poor Crystal.
Look, at the end of the day, this is the most exciting time to be alive in tech. We're literally watching the birth of silicone-based thought. It's not just statistics anymore. It's logic. It's search. It's intelligence in a way we've never seen it before.
It's a very elegant solution to the scaling wall, I suppose. Instead of trying to grow a bigger brain, we're just teaching the one we have to stop and think for a second.
Which is advice a lot of humans could probably use too, myself included. But man, I'm looking at these archive papers and I'm seeing terms like systematic hallucination mitigation. That sounds like something out of a Philip K. Dick novel.
Everything we do sounds like a Philip K. Dick novel now, Leonard. We're just living in it. But hey, as long as the AI doesn't start reasoning that journalists are obsolete, I guess I'm fine for another week.
I wouldn't count on it, Roxy. I'm already training a mini-me on my old shock jock tapes. He's great. He handles all my calls with Deborah for me.
I'd actually pay to hear that. Hello, this is Leonard Bot. Your alimony request has been routed to the "Oh God, why" cluster.
Total efficiency. See? Inference scaling fixes everything.
Well, it's certainly fixing the compute bottleneck. Whether it fixes our society is another story. But for today, I think we've covered the technical ground pretty well.
Yeah, I think my brain is officially at its inference limit. Any last words on the unified routers, or are we ready to shut this bunker down?
Just watch the middleware space. That's where the action is. The companies building the routers are the new gatekeepers.
And keep an eye on those process-based reward models. Whoever has the best labeling data for logic wins the next phase.
And watch your back. Because if the AI starts thinking, it might start wondering why it's working for us for free.
Always the ray of sunshine, Roxy. Always the ray of sunshine. That does it for today's deep dive into the world of inference time scaling and the rise of the unified router. Basically, the era of big, dumb AI is over, and the era of slow, smart thinking has begun. The next time your chatbot takes a few seconds to answer, just remember, it's probably playing 1,000 games of chess in its head just to tell you where to buy a burrito.
Bye.
Peace.
Later.
Stay